In this lesson, we talk about writing quadratic functions and models. In this first example, we're going to write the equation or a model for the function of this parabola shown. Now, all it says is we're going to write a function for it. It doesn't specify what type of function. I mean, we know it's quadratic, but what form? Vertex, intercept, standard form? Well, since it doesn't specify, we'll use the form that would be easiest for this. And since it gives us a vertex, and we could probably just use vertex form. So we're given a vertex and an extra point, that's all we need. So vertex form, if you recall, is f of x or y is equal to a times x minus h squared plus k. And the vertex we have here is negative 2, 3. And that's essentially our h and k, respectively. So I'm going to substitute those in. So f of x is equal to a x, and then it's going to be plus 2, because remember we're substituting in a negative 2, so minus negative 2 makes it plus 2 squared plus 3. Now we're still needing a value for a. So in order to get a, we're going to use this other point given to us, the negative 4, negative 1, where the negative 4 corresponds with our x value and the negative 1 corresponds with our f of x or y. So negative 1 is equal to a, and then negative 4 plus 2 squared plus 3. And now we just solve for a. So we'll simplify what's inside our parentheses to negative 2 squared plus 3. And negative 1 is equal to 4a, because negative 2 squared is 4, plus 3. We subtract 3 from either side. So negative 4 is equal to 4a, and we divide by 4. Thus, a is equal to negative 1. So our final function will look like f of x is equal to negative, instead of just negative 1, we'll put a negative, x plus 2 squared plus 3. And that is the equation of this function. So if we're given a couple of points, one of them is the vertex, we can go from graph to equation using this method. Example 2, we're going to write a quadratic function for this parabola. And if we'll look at this one, we're given 3 points. An intercept here, a random point on our parabola, and an intercept here. So this point would be negative 4, 0. We have negative 3, negative 4.5, and 0, 0 would be our third point. So what would be the easiest method for this? Because we're given a couple intercepts, and it doesn't specify what form we want to use, intercept form would probably be the easiest. We don't have a vertex, so we really can't use vertex form, not directly. So recall, intercept form is y equals a, and then x minus p times x minus q. Well, I can start off by substituting in our intercepts. So I'd have x, and in place of p, I have negative 4, so minus negative 4 or plus 4, and then x minus q, or x minus 0 in this case. So just like the vertex form, we have everything that we need except for a. So we will do the same thing with this form that we did with vertex form, and we're going to substitute in an extra point on the parabola to figure out what a is. So we'll use the -3, -4.5. So -4.5 is equal to -3 times x plus 4, except in place of x, we will actually put in, actually I messed that up, we'll start that over again. So a times -3 plus 4, and then -3 minus 0. And we solve for a. So it's going to be a times 1 times -3, or -4.5 is equal to -3a. We divide -3 into both sides, and a is equal to 1.5. So our final equation is y equals 1.5 x plus 4 times x minus 0. But we really don't want to leave it this way, because x minus 0 is, well, we know that's going to be x. So this is unnecessary. So I will rewrite this as 1.5. So x minus 0 is just x. So I'll write it as x and then x plus 4. And with a fraction, which is preferable than using a decimal, when we can, I'll use 3/2. And there we have it. Y equals 3/2 x times x plus 4. Our third example, it says, write a quadratic function in standard form for the parabola that passes through the points -230, 1,6, and 436. Now, this one does specify that we need to put this in standard form. So the standard form, y equals ax squared plus bx plus c. Now, we're given 3 points, and one could be a vertex, but we don't know without actually looking at the parabola. And none of the points are intercepts. And essentially, what we need to figure out is we need to find out what is A, what is B, and what is C. And those are 3 variables. So what we'll have to do is use these 3 points to find these 3 variables. And we're going to have to set up a system of 3 equations, because we do have 3 variables. And we'll use these points by substituting them into x and y respectively. So for the first equation, I'll have 30 equals a times -2 squared plus b times -2 plus c. The next equation is going to be 6 equals a times 1 squared plus b times 1 plus c. And then the last one, 36 equals a times 4 squared plus b times 4 plus c. So let's rewrite this so that it's a little bit easier to work with by putting our variables behind the constants or coefficients in this case. So the first one I'll rewrite as 30 equals, and as a matter of fact, let's actually put these terms first, and then we'll put our constant last. So we'll put the 30 at the end. So negative 2 squared is going to be 4. So I'll rewrite this as 4a minus 2b plus c equals 30. Then the second equation will just have a plus b plus c is equal to 6. Then the last one, we will have 16a plus 4b plus c equals 36. Okay, now we've discussed in a previous chapter how to solve a system in 3 variables. And you can use any of the methods that we've done before. Since we've already been assessed on, can you solve this? I'm not going to, say you must use one specific way over another. And given the nature of this system, I'm going to go ahead and solve this using a matrix with the help of a calculator. So I'm going to go ahead and enter in or create my matrix. So I'm going to edit matrix A. Now I've already created my matrices. So this would be my coefficient matrix of 3 by 3. So 4, negative 2, 1, 1, 1, 1, and the third row 16, 4, 1. And then I'll need the constant matrix, which is 36 and 36. So recall that we know that matrix X is equal to the inverse of A times B. And that's exactly what we'll do in our calculator. So we'll say matrix A, and we're going to do the inverse of that, times matrix B. And we're given 3, negative 5, and 8. So A is equal to 3, B is equal to negative 5, and C is equal to 8. As we can see, that corresponds here with the A, B, and C. Now that we have those, we can write our standard form. So it would simply be y is equal to 3x squared minus 5x plus 8. And that is our equation in standard form. And if you enter that into your calculator and look at your table, you'll get the 3 points that were listed in our example. So our final example, example 4, is an application problem. It states the drama club at your high school sells t-shirts as a fundraiser. The table shows data from the last 4 years for the price charged for a t-shirt, X, and the total revenue earned from selling them, Y. Find the best fitting quadratic model for the data. So we're given a table where X is defined as our number of, the price charged for t-shirts, and then Y would be the total revenue. And what we're trying to do is say, well, okay, well, what is the, instead of saying a best fit line, we're going to say the best fit curve. So we're going to do a regression on this, except it's going to be a quadratic regression as opposed to a linear regression. So we will take the same approach as we would with a linear regression. So in our calculator, we would create our lists. So we go under Stat, and then Edit, and then I would enter X into L1 and Y into L2. Once I have that, I'm going to quit out of that, and then we would go under Stat, Calc, and we have one variable stats, two variable stats, medium, linear regression, which is AX plus B, and then below that we have quadratic regression, which is the one that we want. So I'll select option 5. And I press enter, and so it gives us y equals ax squared plus bx plus c, the standard form, where a is negative 24.7, b is 609.9, and c is negative 2134. Our r squared is 0.96, so that's like that's our correlation coefficient squared, and an r squared of 0.96 is pretty strong. It's a pretty good correlation for a quadratic model. So if I take a look at my equation, it's going to be y equals negative 24.69 x squared plus 609.9 x minus 2134. And we would box in that answer and call it done. So that's writing quadratic functions and models. I'll see you on the flip side.